Hello and welcome to the optional part of module number 4, Enhancements to the User Interface. At the end of the implementation of the statistics and the scoring iteration 5, I showed some of the issues we have with the user interface, particular that the user can click on the start game at any time, causing the game to reset while playing, and the user can click on the answers many times, causing the alert to display multiple times, and of course causing the game scores and stuff to get all messed up. So we need to use the concept of least privilege, meaning that make the user interface available to the user only when they need it. So we start with the start game. In order to control whether the button is enabled or not, I am manipulating the data of those different buttons. In order for the controller to have access to the buttons to change its attributes, we need to connect them as outlets. So I will connect the start button as an outlet, and we'll start with the start button for now. So as an outlet, and I'm going to call it button start, btn start, and then connect. So I have the start button connected to my view controller class. Then the button should be active until the user click start game. So once the user starts the game, we reset the game, and before we reset the game, actually once the user clicks start game, they should start the game and disable that button. So in step 0 here, I will say disable the start button. I'll say button start dot enabled. The function is called enabled, or the variable is called enabled, and it's of type boolean, and then I will say false. So now that will make the button disabled, so the user cannot click on it. So we need to make the button enabled again when the game is over. So where is the game over? The game is over in the end game function. After we do the present the animation, and after we update the stats, or before we update stats, it doesn't matter. Probably after we update the stats, so we make sure that all the scoring values are correct. So after update the stats, I'll say enable the start button. So I say button start dot enabled equal true. So the start button is simple because it is outside the actions of the game. So you just need to disable it in the beginning of the game and enable it back again at the end. Let's try that before we move on to the node buttons. So when the game loads, you'll notice once you click the start game, you no longer can click on the start game. So I'm clicking on it, but it doesn't do anything anymore. So let's play a game. And once we are done with the game, now we can click the button again. So you can only click the button when the game starts. We want to do the same thing with the node buttons. However, the node buttons, there are several of them. If I connect each one of them as an individual outlet, like the start button, there will be 12 of them. Then to enable them, I'm gonna have to write that sentence 12 times for each one of them. Then anytime I need to make a change to their status, I will need to write them 12 times again. That's not efficient. Since all the buttons are of the same type, the action I need to perform on one of them is the same that I need to perform on all of them. I can put them all inside one array, one collection. But you say, but these are outlets. Yes, and there is something called outlet collection. And you'll see here, under connection, there's an outlet, there's an action, and there's an outlet collection. We have not used the outlet collection yet, and we will use it right now. So this is an outlet collection. The type of each item of the outlet is called the UI button, that's the type. And the collections, we're gonna call it note buttons collection and connect. So you'll see here how they connect IB outlet variable node button collection. The type is an array type. The square bracket surrounding a type, meaning that you want to create an array of that type. And then the exclamation mark at the end because we didn't change. We don't want to change. I'm not gonna need that. Oh, actually, I still need it. So here, I connected only the A button with the collection. I need to connect all the buttons so that the collection is linking to all the outlet buttons. So I'm connecting from the variable to the buttons using that circle. When you hover over it, it's a plus. Or you could connect to the rest of them the same way we connected the A button by pressing the control and dropping on top of the actual function and actual variable. Now all those buttons, I need to do exactly the same thing. So I'm gonna create a function. That function responsibility is to take a Boolean variable for the status and set the enabled property or attribute to that Boolean variable. This way, any place in the program where I want to enable or disable the node buttons, I'll just call that function and say true or false and so on. So let's see how this would work. So I need to go somewhere and add that function. So I'll come here and add a function. And I'm going to say set note buttons status. And this function needs to receive a variable. So I'm going to call it variable status. The type of that variable is Boolean. So anyone who wants to change the status of the node button collection will need to call that function and pass to it an argument, and that argument should be of type Boolean, meaning a true or false. So I would then want to do something similar to that. Button enabled equal whatever the status is. But in order to apply the enabled property, I need a button. I don't have a button, I have a collection of buttons. So you can say, well, can I use the object at index 0, 1, 2, 3, 4, 5, 6 all the way to 12 and retrieve each one of the buttons in one variable and set it to enable or disable? I'll say yes, you can. The problem is, if you do that, you will have 12 different instructions for the 12 different buttons. This is inefficient, and if you want to decide to change something, you have to repeat it 12 times. And if suddenly we have 15 variable, you won't be able to do it. So the solution here is to introduce, we introduce to you another construct. We introduce the if statement. We here will introduce the for statement. Iteration is allowing you to repeat a single instruction multiple times. So if I want to enable one of the buttons, instead of writing that 12 times, I'll just put them in a for loop. So one line of instruction, but there's a loop that will repeat that line for as many times as you would like. There are two different types of for. There's a for loop that works with a collection, which is the one we're going to use. It goes like that, for. And the idea is that you're going through the node collection, the node button collection, retrieving one item at a time, putting that item in a local variable, and then applying whatever features or functionalities you would like. So I'll say for, and then the name of the local variable to assign that item, that one item at a time to. So I'm going to call it for note button. And then you use the keyword in, and then you provide the name of the collection. So for node button in node button collection, and then you define the scope of that for statement, or the block of code for that statement. The way this works is the for loop will go to the collection, will retrieve the first item at index 0, assign it to this variable name that you define. Since Swift infers the type, the node button doesn't need to have explicit type, because Swift will use the type of the item from the node button collection, which is UI button, and make it the type of this node button. Within the block of the for loop, node buttons has a scope, and it references a single button at a time. And when the for loop ends, instead of proceeding and ending the function, it goes back to the for loop, retrieve the next item from the collection, go through the block of code, then go back to the for loop, retrieve the third item from the collection, assign it to this variable, go through, make whatever need to happen, and keep doing that until there are no more items in the collection. So for node button in node buttons collection, and all what I need to do now, I have a reference to a single button, and notice here node button is a UI button because it's inferred the type node button dot enabled equal status. Now the reason I have this variable status here is in case is to enable me to use the function both to enable as well as to disable. So if status is true, I'm enabling. If status is false, I'm disabling. When do I do that? Depending on where you want them. So let's start from the beginning. When the game loads in the beginning, when the game loads, we don't want the buttons to be enabled, because otherwise the user can click on the node buttons before they start the game. So when the game loads, none of the node buttons should be enabled, only the start game, help, and the statistics. When the game loads, that takes place in viewDidLoad. So then I need to come in viewDidLoad and say disable the node buttons. So I'll come here, and now how do I disable them? It's not like I did individually. I now have a function that I can call on. So I'll say set node button status, and then it says what is the status that you want. So I will say I want false, meaning that I'm disabling them. Then the user click start game, which will take us to the play game. The play game will reset the turn, will play random note, and once a random note is played, I need to enable the button. So I'll say here enable note buttons. So I'll say set node button status. Now it is going to true. So the sound displayed, the note buttons are available. The user will click on one note button, which will take us to the check answer. Once the user click on one note button and take us to check answer, they should not be able to click any of the other note buttons. So then I need to disable them again. So I come here in the beginning and say disable note buttons. So I'll say set note button status to false. Then the check answer will drive the user back to the play game for the second iteration. In the play game, we reset the turn, check the turn counter less than maximum turn. If it is true, it plays a random note and set the note status to true. Then the user can click. When the user click, we go to the check answer. The check answer turn them off. Check the answer and send you back. When you are back to play game, you make another sound and you turn them on. And then it turns them off. And then when you're done, when they come to play game, they are off. So if there are no more turns, they remain off. And you go to end the game, where they remain off, and now the start button becomes true. And then the user can go one more time. So that looks like all we need to do. Disable the buttons in view did load, and then enable the buttons again when you play the sound. So here are all the buttons now disabled. I click start game. Now start game is disabled and I'm ready to make an answer. So I make an answer. All the buttons are disabled until another sound is played. So the buttons are enabled. And once you click on one of them, you can't click on anything else until you are done with all the buttons. And when the game is over, the start game becomes active. All the note buttons become inactive. And you can keep playing that. And now we locked the game so the user cannot make any mistakes or click on something when they are not supposed to click on that something. The last enhancement I want to do or show you is that color. So I currently colored all the correct, incorrect to red. So I want to change that. So if the answer is correct, I want to color it to green. If the answer is incorrect, I want to color it to red. So I don't need the storyboard for that. So I'll switch directly to the view controller. And I don't need that output window. So the check answer is where we put the answer, correct answer. So before I display the correct answer for the label, I want to change the color. So I say label answer dot text color. Here is the text color, which receive a color object or needs a UI color object. So I can use the UI color. You can create a color of your choice by same way we did in module number 2 by using this initializer and provide a float, green, and so on. Or you can call on one of the preset colors. So there are preset colors or functions that give you some preset colors. I want a green one. So there is a green color. So I will say it's a green color if the answer is correct. And then do the same for the incorrect. But in the incorrect, I want to have it as red color. So UI color and call on the function red color. So let's run that. And you can set any of the other properties of the label as well, not just these. So let's do a correct answer. So now the color is green. And let's do an incorrect answer. So the color is red. Let's do another correct answer. And the color is green. So that's it for the enhancements and for this module number 4. I hope you enjoyed it, and I hope that you found the game useful and challenging, and provides a lot of features of the app development that we learned together. So I hope you complete this and add your own features. You can modify the model, you can modify the view, and you can modify the functionality by adding even some more. You can add a button to play the sound again, or think of different things that you would add. Thank you, and next we'll move to module number 5.